In this video, we'll be graphing ellipses. So let's graph the equation x squared over 64 plus y squared over 100 equals 1. We want to state the center, the vertices, and the foci. So you'll notice that we don't have any parentheses in this equation. When we saw the standard form of our ellipse, it was x minus h squared plus y minus k squared equal to 1. And we know that we have a squared and b squared underneath depending on which direction we're opening big. A squared is always bigger, so in this example, our 100 is our a squared. All right, but this equation does not have the parentheses around it, so that tells us that our coordinates for h and k, our center, is the origin. So here we have a center of 0, 0. It's always easiest when our center is on the origin. Next, we want to figure out where the vertices are. We're going to use the major axis to find the vertices, and then we'll use the minor axis to help us find the other direction of our ellipse. If you recall, our major axis is of length 2a, and our minor axis is of length 2b. I don't get so caught up in the a and b, though. So I see that I have 64 under x squared. I'm going to take the square root of it, and then I'm going to go that many units from my center in the x direction. So the square root of 64 is 8. Here's my center at the origin. I'm going to go 8 in the positive and negative x direction. Then I move on to the y. I have the number 100 underneath the y. The square root of 100 is 10, so that tells me that I should go 10 in either y direction from my center. So I'm going to go up 10, and I'm going to go down 10. And that's really all I need to draw in my ellipse. So now let's try to make some kind of nice looking oval out of this. They're never perfect. There we go. So there's our ellipse. Oh, the directions asked us to state the center, the vertices, and the foci. The vertices we can get easily. We know the vertices are at the end of the major axis, so our vertices are going to be up here and down here, but let's label them with ordered pairs. Vertices 0, 10, and 0, negative 10. Make sure you're writing that as an ordered pair. If you wanted to write 0, comma, plus or minus 10, I'm okay with that as well. So now we want to identify the foci, and there's going to be 2 of those. They're going to be somewhere on our major axis. But in order for us to find the foci, we need to find our c value. And recall that our c value, c squared, is equal to a squared minus b squared. So basically, it's just the square root of the big denominator minus the little denominator. So c squared is going to be equal to 100 minus 64. C squared is equal to 36, making c equal to 6. Make sure you're taking the principal root here and not coming up with negative 6. All right, so our foci are c units away from our center along the major axis. Here's our major axis. So I'm going 6 units away from my center. So 6 up and 6 down. My foci are the ordered pairs 0, 6 and 0, negative 6. All right, let's take a look at another one where our center is not right on the origin. Same directions. We're going to graph, state the center, vertices, and foci. On a quiz or a test, I might ask for domain and range as well. So make sure that you are answering all of the questions in the directions. Well, the first thing I notice about this one is I have the parentheses, so that tells me that my center is going to be off of the origin. But this one, I don't have two fractions, and I feel more comfortable when I have two fractions. So the first thing I would do is I would throw the second part over 1. And next we can identify our center. Just like circles going from the equation to the center, it's the opposite sign. So our center is going to be the point -2, 3. Once I get the center, I go right to the graph. I'll find the vertices and the foci after the fact. Notice that this one is going to be long in the x direction since the big number is under the x, so it's going to be wide horizontally. We're going to go the square root of the number in the denominator in each of our directions. So the square root of 16 is 4. So I'm going to go 4 off the center in the x direction, and then the square root of 1 is 1. So I'm going to go 1 off the center in the y direction. So let's get this center plot. -2, 3. And we said that we were going to go from here 4 in the x direction, so go on either side. And then we're going just 1 in the y direction from the center. It may be helpful for you to label the center C or something so you don't end up going off of the wrong point. But this is all we need. Now we're ready to draw our ellipse in. Let's do the best job you can. I'm not going to be super fussy about it. Okay, great. Our vertices are the endpoints along our major axis, and our major axis is the long way. So we have our two vertices here on the end. We'll write those as ordered pairs. I'm just going to count from the origin. -6, 3 and +2, 3. You know, I think I'm just going to write them right here so I don't have to keep scrolling. So our vertices, -6, 3 and 2, 3. And then we also want to find our foci. In order to find our foci, we're going to go C units away from the center along the major axis. So I need to find my C value. Remember that C squared is equal to A squared minus B squared. Or C squared, I'm going to take my big denominator, 16, and minus my small denominator. We get C to be equal to the square root of 15. So I'm going off my center, square root of 15, along the major axis. You definitely do not want to create a decimal approximation for this. We're beyond that. We want exact answers, so we're keeping the square root of 15. Since our ellipse is long in the horizontal direction, it's going to be our horizontal component of our center that changes for the foci. Like, for example, if they're here and here. I'm just totally making this up, right? Notice that the y value for the foci maintains the same value as the y value for our center. So it's only the x value that's changing, and it's changing square root of 15 to the left and square root of 15 to the right. So I think the easiest way to write this is you start with your x coordinate of your center, which was -2, and now we're going to either add or subtract square root of 15 to get our foci, and then the y coordinate of our center stays the same. All right, let's try one more that is in general form instead of standard form. So you'll recall going through this with circles. Standard form has the parentheses. General form is all multiplied out. General form is not very useful for us with our conic sections because it doesn't tell us anything. It doesn't tell us where the center's at. It doesn't tell us how big our ellipse is. So we always want to transform something from general form into standard form. The way that we're going to do that is by completing the square. The technique we're going to have to use here for completing the square, though, is different than what we did when we completed the square with circles. With circles, the leading coefficient on x squared and y squared was always the same number. That's what made it a circle. You'll notice that the leading coefficients on our x squared and y squared terms are different here. So it's not like I can just divide through by 4 because that's not going to create a leading coefficient of 1 for both x squared and y squared. So we're going to have to use a factoring technique for completing the square. And you may or may not have seen this before, so I'll take it slow. This problem's going to take me about 10 minutes, and we're 10 minutes in, so if you need to pause and take a break, do that. But I'm going to get myself organized. I'm going to get my x terms together. I'm going to get my y terms together, and then I'm going to move my constant over to the other side. We're going to have 4x squared minus 32x. I'm going to leave a little space. Plus 9y squared plus 36y. I'm going to leave a little space and then move my constant to the right side. As I mentioned before, I can't just divide by 4 here or divide through by 9 here. But we know our leading coefficient has to be 1 in order to complete the square. So how we're going to manipulate our equation into that form is I'm going to focus just on the x's. And another way to make my leading coefficient 1 is by factoring a 4 out. So I'm going to factor 4 out of my first two terms, which is going to leave me with x squared minus 8x. And now I'm going to leave a space here. We'll do the same thing with the y. I'm going to factor a 9 out. That leaves us with y squared plus 4y, and then I'm going to leave a space in my parentheses, and then we're equal to negative 64. All right, we're ready to complete the square for x's. We're going to start this like normal. Okay? B divided by 2 squared is what we need to add to create a perfect square trinomial. So I'm going to take the b value here for the x, which is negative 8, divide it by 2 and square it. That's negative 4 squared, which is 16. So that's what we add in here to create a perfect square trinomial. But we know if we add it on one side, we have to add it to the other side. But here's where it's tricky. We're not going to add 16 to the right side. See, the overall value of that constant on the right-hand side is actually 4 times 16. So you have to distribute that 4 back in, at least in your mind, before you add the constant to the other side. So we're actually going to add 64 over here and we got that from distributing in the 4 times 16. We know that this perfect square trinomial always factors into the form x plus b divided by 2 quantity squared. So I'm still going to do that just like normal with completing the square. We just got that 4 hanging out in front. This is going to be 4 times the quantity x minus 4 squared. And now we'll do the exact same thing for the y's. We're going to take its b value, which is positive 4. I'm going to divide it by 2 and square it. So 2 squared is 4. That's what I'm going to add in the parenthesis, but that's not actually the value of the constant on the left side. We need to multiply it by the 9 before we add it to the other side. We're actually adding 36. Let's turn this perfect square trinomial into its factored form. This becomes 9 on the outside, y plus 2 quantity squared, and then we can add up the constants on the right side, and we get 36. Wonderful, we've made it through the completing the square portion, but we're still not quite in standard form. Remember that our standard form is always equal to 1, so what we want to do now is divide through by whatever that constant is on the right-hand side, because that'll make it equal to 1. Simplifying, x minus 4 squared over 9 plus y plus 2 squared over 4 is equal to 1. And now we've transformed our equation from general form to standard form, and we can get it graphed. We'll start by identifying our center. Remember, from the equation to our center, it's opposite signs, just like circles. So we get a center of 4, negative 2. This ellipse is going to be long in the horizontal direction because our big number is underneath of the x. Oh, we'll get our center down, 4, negative 2. And now we take the square root of the number underneath, so we're going to go 3 in the x direction from the center and 2 in the y direction from the center. And then we have the 4 points that we can draw in our ellipse. Go. Our major axis is here in the long direction, so we know those endpoints on the major axis are our vertices, so let's get those labeled. 1, negative 2, and 7, negative 2. The last thing we want to identify are the foci. Our foci are a distance c away from our center along the major axis, where c squared is equal to a squared minus b squared. So let's find that c value. So it's always c squared equals the big denominator minus the small denominator. Then I don't have to worry about that whole ab thing. OC squared is equal to 5, making c equal to the square root of 5. Because our ellipse is long in the horizontal direction, that means that we are going to add or subtract the c value from the horizontal component, or the x value of our center, while the y value will stay the same. Our foci are going to be located at 4 plus or minus the square root of 5, comma negative 2.